Hello, welcome to the course Python Programming for Beginners. In this lecture, we will discuss one of the open source Python library, that is Matplotlib. So in this, first we will see the overview followed by the installation with one simple example demonstration, then various parts of a figure in Matplotlib, then types of inputs to plotting function. These are all the various topics we will see related to Matplotlib. Okay, this is the official website where you will get the full resources related to Matplot library. So matplotlib.org. Here you will get all the resources. This is official website of Matplotlib. Okay, in our earlier lectures, as part of introduction of open source libraries in Python, we already discussed briefly about Matplotlib. Once again, a review. Okay, Matplotlib, which is a standard data science library that helps to generate data visualizations, such as two-dimensional diagrams and graphs. Graphs means like histograms, scatter plots, non-Cartesian coordinate graphs, etc. Matplotlib is one of those plotting libraries that are really useful in data science projects, which provides an object-oriented API for embedding plots into applications. Python can compete with scientific tools like MATLAB or Mathematica. However, developers whenever wants to write more code than usual while using this library for generating advanced visualizations. So here, the popular plotting libraries work seamlessly with MATLAB. MATLAB is also a comprehensive library which is used to create static, animated, and interactive visualizations in Python. Matplotlib also makes easy things easy and hard things possible. So first it creates publication with quality plots, makes interactive figures which can zoom, pan, and update, customizes visual style and layout, exports to many file formats, embedded in JupyterLab and graphical user interfaces. Also having rich array of third-party packages which was built on Matplotlib. These are all some of the advantages of Matplotlib. Then how to install Matplotlib? So if we have already have Python, we can install Matplotlib using pip, which is a PyP. That means Python package index. Simply you can use the statement pip space install space matplotlib. Here pip is a package manager for Python packages or modules. The alternative way of installation whenever using Anaconda. So install using Conda. Here Conda space install space -c say space Conda -forge space matplotlib. Here, Conda is a cross-platform package and environment manager that installs and manages Conda packages from the Anaconda repository as well as from the Anaconda club. These are the two ways of installation of Matplotlib. Let us see how to install Matplotlib using official Python IDL. So in our system, press the Windows key with your keyboard. Then you can go to the command prompt by typing cmd, open command prompt. Then a black terminal should open up. Then there you can type pip space install space matplotlib and then enter. Then it should start the installation. After you see the successful install message, go back to our Python IDL and try importing matplotlib. Then it should work. is the simple straightforward installation process. Let us see. This is the command prompt terminal. Here, simply we typed the statement pip space install space matplotlib, then you can enter. So then the installation started. Once successfully installed, so then here you can see at the end what we are seeing, successfully installed. So then you can go back to your ideally, then you can import automatically, it works. Okay, then how to import Matplotlib in our Python ideally? So to access Matplotlib and its functions, we have to import in our Python code like this. Import space Matplotlib. You can create one object of Matplotlib MPL as with alias. Here we shorten the imported name to MPL for better readability of the code using Matplotlib. So this is a widely adopted convention that we should follow so that anyone working with our code can easily understand it. Simply you can use import matplotlib as MPL. Any some of the other modules related to matplotlib also you can import. Let us see first one simple plot diagram using Python code how to draw. So draw a first plot. First, you can import Matplotlib. Here we are taking pyplot is one of the plot category. So import matplotlib.pyplot. We are creating one alias name as plt. Here plt means object of pyplot. Then here, whenever if you want to draw any plot, we need numerical data. For that, we will use NumPy array. In our earlier module, we already discussed about NumPy. You can import NumPy. Import NumPy as NP. NP is the NumPy object. plt is the pyplot object of Matplotlib. Now, whenever you are drawing any plot, what you need, so you require x-axis and y-axis values. Here you will get some plot graph type. Okay, then how to define x, how to define y. Here x we are taking some random values with linearly separable space by taking 0, then the end value is 200. So in between the calculation is 2 into np dot pi. So it substitute the value in this condition starting with 0, then the value 0, some 0.1 like that, it increases with the pi value. Then y-axis value we are taking sine values, y equal to np dot sine of x. Here whatever the x value you will get, then sine of x value is the y-axis value. So then using the object figure comma axis, you can define the figure, then axis using plot plt, which is the object of pyplot from matplotlib, then using subplots method. So then how to do the plotting with axis dot plot of x comma y. Here x we know, y we know. So using the plot method. Then finally any plot you want to see in the entire of Matplotlib, you can use show method. Simply the object of Matplotlib plt.show. So whenever you can use this statement, automatically the plot is displayed. Let us see the output of this one. So this is the output of the code what we explained. Here you can see here this is the x-axis. Now this is y-axis. Here you can see the x-axis values what we are taking 0, 2. Here we have taken one condition. So that is 2 into pi. 2 into np dot pi comma 200. This is the range values. X-axis what we have taken. Then y-axis what we have taken, sine of x value. np dot sin of x. Here np dot sin of x. So here x values are as per this condition 0, 1, 2, 3, 4, 5, 6. The last value by substituting in this condition. So then y values, here you can see sin of 0, then sin of 1, then sin of 2, sin of 3, and so on. So these are all sin of x, y equal. So this is the simple plot of the previous code what we demonstrated. Now lively you can demonstrate the same program. Let us see the output. Okay, open your Python IDL. Okay, whatever the code we explained, let us see. Okay, this is the Python IDLE. Simply you can copy code somewhere, then step by step you can run, or you can copy in your file, then open that file. First you have to import Matplotlib. Here we are importing pyplot from Matplotlib, creating its object as plt. Then what you have to do, you have to import numpy. The object is np. Import numpy as np. Then define x value, x equal to np dot linear space of 0, 2 into np dot pi, 200. Now x value is defined. If you want to see the x values, let us see. These are all the x values, the array. Here you can see. These are all the x values. Okay, then define y value, y equal to np dot sin of x. If you want to see y value, just simply type y. Total 50 lines are there. You want to see, click on view. Yeah, these are all the y values starting with 0.02. Let us see. Now x and y values are defined. Now you can define figure and axis with two objects, figure comma axis equal to, using subplot method from the module plot. Now the figure and axis are created. Then you can define the plot using the axis x and y. So ax dot using the plot method, plot of x comma y. Here just acknowledge message is displayed for this plotting method. Is like a 2D object at so and so. Then finally, you want to see the plot or graph. Simply you can use the method plt.show. Here you can see this is the graph what we have explained. So here in Matplotlib, you can save any plot with any format. Here you can see save this figure. Here you will save this figure in the JPEG format, PNG format, or doc format, or PDF format, whenever you want for printing or references. So this is the output of the plot what we explained. So whenever you can move the cursor, it shows the x and y coordinate values. Here you can see the bottom. Here you can see whenever you are placing cursor on the graph, bottom you can see the values are changing x and y, the coordinate values, the position values. So this is the simple plot. Okay, let us see about the components of plot with a detailed explanation. Okay, here we used the method pyplot from the module Matplotlib. So what exactly this is? Matplotlib.pyplot is a collection of functions that make Matplotlib work like MATLAB. Each pyplot function makes some change to a figure. For example, creates a figure, creates a plotting area in a figure, plots some lines in plotting area, decorates the plot with labels, etc. These are all the changes done with the pyplot function. Here, Matplotlib graphs our data on figures. Example on Windows, Jupyter, widgets, etc. Each of which can contain one or more axes. An area where points can be specified in terms of x, y coordinates, or theta r in polar plot, or xyz in 3D plot, etc. So one of the simplest way to creating a figure with axes using pyplot.subplots. Just now we have seen the program. We can use axis.plot to draw some data on axis. Okay, here you can see in our earlier code we used figure comma ax with the subplot method using plot plt.subplot. Here create a figure containing a single axis, this one. Suppose here you want to do some data on the axis. Here ax dot plot of, directly you can give the data 1 2 3 4. Suppose 1 4 2 3, let us assume some data ax dot plot of. Earlier we used x comma y. Here directly we are giving the data x and y. So then you can see this plot using plt.show. Now let us see the output of this code. Yeah, for this data, whatever the data we have taken 1 2 3 4, then here see the first 1 2 3 4 1 4 2 3. So between these, this is the x area, this is the y area. This is the sample plot of the sample data taken. So like that you can customize our own data also for x and y coordinates. This is another simple example. Now let us see the components of a figure. So here, what are the parts of a figure? The components of a Matplotlib figure. This is one sample Matplotlib figure. Here you can remember each and every component and its code also mentioned here. So here you can see the first one, the serial numbers are given. This is the one. So what is this one? Actually, x-axis. So x-axis is defined as ax dot x-axis. Then coming to 2, so that is the x-axis label. So the label is defined as x label. So ax dot set underscore x label. This is the statement we have to use it whenever you want to set the label. Then the third one, if you want to define tick labels, minor tick labels. So minor tick labels, like here you can see these dashed lines. So for that the statement is ax dot x-axis dot set underscore minor underscore formatter. This is the method for defining minor tick label. Then the fourth one, which is called as spine. Here in the diagram you can see this is the spine, thick one. So you want to define this spine, use the statement as ax dot spines. Then coming to the next component, let us see. Next you can see similarly y-axis, ax dot y-axis. Then measure tick you want to define ax dot y-axis dot set underscore measure underscore locator. If it is minor, minor underscore formatter for x-axis or y-axis, whatever. Then for y label, ax dot set underscore y label. Then measure tick label for y-axis, ax dot y-axis dot set underscore measure underscore formatter. Then similarly for y-axis minor tick mark, ax dot y-axis dot set underscore minor underscore locator. Then you want to define line in a plot. So ax dot plot, simply line. You want to define grid format. This is the grid. So grid type graph. Here simply you can use ax dot grid. Then you want to define markers. Here you can see these are all markers type. Like we'll call it as scatter. Ax dot scatter. Then you want to define axis. Here you can see fig figure dot subplots. Earlier, the previous program what we demonstrated, we used axis, x and y axis. So this is one graph, x and y axis combination using subplot method. Then here you can see to define the color combinations. Suppose here blue signal, orange signal. Actually, this will call it as legend. This is defined as ax dot legend. This is the method. Then a title you want to define title of our graph or figure. We can use the method ax dot set underscore title. This is the title. Then figure. So how to define the figure? Plot dot figure. So these are all the various components of a figure of Matplotlib library. So in our code frequently, we may use some of these regularly. So you can remember this figure. Okay, here whatever you mentioned figure, which is a whole figure. So the figure keeps track of all the child axis, a group of special artists like titles, figure legends, color bars, etc. and even nested subfigures. The easiest way to create a new figure is with pyplot method, which is part of Matplotlib. Then this is another example. The easiest way to create a new figure is with pyplot. So you want to create new figures from the existing one. This code demonstrates that. First we are defining figure, plot dot figure, an empty figure without any axis. Then you are creating a figure with a single axis. Figure comma ax equal to plot dot subplots. Then we are creating a figure with 2 by 2 grid of axis. Same figure comma axis equal to plot dot subplots of 2 comma 2. Here 2 comma 2 means it is 2 by 2 grid. Then another here a figure with one axis on the left and two on the right. So the another one. Here you can see figure comma axis equal to plot dot subplot underscore mosaic. The format is called as mosaic. So left that will be at right top, then left at right bottom. Here, so one axis on the left and two on the right. So then you want to see the output of this plot. Simply use plt.show. Now let us see the output what you will get here. First you will get a figure without axis, figure 1. Then figure 2 with x and y, simple. Then figure 3, here you can see, here we are having 1, 2, 3, 4 grids. This is 2 by 2 grid. Then figure 4, see this one is left, then right, top and right bottom. These are all the combinations you will get. So let us run this program. We will also check the output. Whatever Python ideally, what the code is already copied here. So create a new figure with a pyplot. We already imported this one. Now directly you can take figure plt dot figure, then define one plot without any axis, figure comma ax equal to plot dot subplots. Then another one with 2 by 2 grid. So figure comma axis for defining another object, plot dot subplots 2 by 2. Then another one with mosaic format. Then you want to see the plot dot show. Here you can see. Here you can see total 4 figures are displayed at a time. Let us see one by one. This is figure 4. This is figure 3. This is figure 2. This is figure 1. So figure 1, here first one you can see. Fi is equal to plot dot figure. Here no axis. It is empty. This is empty figure. Then second figure, what we are doing here, you can see one. You are taking one axis, plot dot subplots, simple axis. This is figure 2. Here you can see x and y axis. Then the third one, what we are taking with 2 by 2 grid, the figure with 2 by 2 grid. Here you can see this is 2 by 2 grid. This is the figure 3. Then finally, the last figure, you are taking mosaic with the combination of, let us see. So left, right, bottom, then left, right, top and right, bottom. So this is the left, then right, top, then left, right, bottom. For this left, top and bottom, here two combinations. This is the figure 4. So like that, you can create new figures from the existing combinations. So using Matplotlib. Then here we use the another important component axis. So what is axis? An axis is an artist attached to a figure. What it contains a region for plotting data and usually includes two axis objects. In case of 3D, 3. Here you can observe the difference between axis and axis. Both are different. So which provides ticks and tick labels to provide scales for the data in the axis. Each axis also has a title, set underscore title, an X label, set via set underscore X label, and an Y label, set underscore Y label. This was already mentioned in the figure. So here the axis class and its member functions are the primary entry point to working with object-oriented programming interface and have most of the plotting methods defined on them. For example, ax.plot shown the above, which uses plot method. That is about axis. Then coming to axis. So this object set the scale and limits and generate ticks, means the marks on the axis, and tick labels means the strings labeling the ticks. The location of ticks is determined by a locator object, and the tick label strings are formatted by formatter method. The combination of the correct locator and formatter gives very fine control over the tick locations and labels. This is about axis. Axis and axis both are different. Then the next component is artist. Basically, everything visible on the figure is an artist, even figure, axis objects. So this includes text objects, line with the two-dimensional object, collection objects, patch objects, etc. When the figure is rendered, all of the artists are drawn to the canvas. Most artists are tied to an axis, such as an artist cannot be shared by multiple axes or moved from one to another. Then types of inputs to plotting functions. Plotting function expect numpy.array or numpy.ma.mask underscore array as input, or objects that can be passed to numpy.asArray. These are the various methods to provide inputs to plotting functions. Here, classes that are similar to arrays means array-like, such as pandas, data objects, and numpy.matrix. Here may not work as intended. Common convention is to convert these to numpy.array objects prior to plotting. Then how to convert this one? Let us see one example to convert a numpy.matrix. Here the following example which converts to a numpy matrix. Here first you are importing numpy, import numpy as np. Now we are taking matrix 1, 2, 3, 4 combinations that is stored in B. Then now this type is matrix type. Now you are converting into array type. So using as array method, np.array of b, that is stored in, let us assume b underscore as array. Whenever you can call b underscore as array, this is array type. Whenever you can print this one, it prints like matrix. So let us see this program. Even you can see the type. Here you will get its type is of matrix initially. After conversion, its type is of array. So here first you can import. In the previous program, we already imported NumPy. Then creating one matrix. Here you can see. Whenever you can call B, this is the type matrix. Here you can see. Now you are converting matrix to array. np dot as array. Now you can see. Simply you can call b underscore as array. So you are getting array. Now earlier it is matrix type. Now that is converted into array type. Before giving this data to plotting, we have to convert the normal data to that array format. Why? Because it takes the NumPy data always. Here most methods will also parse an addressable object like dictionary by using numpy dot rec array or pandas dot data frame. These are the methods. Matplotlib allows us to provide the data keyword argument and generate plots passing the strings corresponding to both x and y variables. This is another example program. Here we will see another type of plot here. First, as usual, we are importing NumPy. Then you are taking plt from the py plot. Again, we are using py plot. Here we are taking the random numbers, seed values, np dot random dot seed of some random value. Here data we are taking with labels a from np dot a range with 50. Then C np dot random integer 0, 50, 50 combination. Then D values np dot random with the 50. So here we are taking A, C, D. Then we are defining data for B equal to with combination of data of A plus 10 into np dot random number 50. We are defining data for B. Then data of D, we are defining np dot absolute of data of D into 100. Then you are defining a plot figure comma ax equal to plot dot subplots. Here we are making one standard figure size fig size equal to 5 comma 2.7. Here a height and width. Then layout we are making it as constraint. Wherever the figure is restricted with so and so size, then the layout we will call it as constraint. Okay, now we are defining the plot type as scatter. So scatter means it defines this type of rectangle boxes. Ax dot scatter, we are taking A data, B data, C data, then S, we are taking D, then data equal to data. Then you are setting the labels also using set underscore X label for naming X-axis label. Now entry A is the label of X-axis. Similarly for Y-axis label, entry B. So Ax dot set underscore Y label. Now you can see the graph here by using plot.show. Here, this is the scatter plot graph. Here, x-axis, whatever the label we used, x underscore label. So entry A. Now this is y-axis label. Entry B, what we have mentioned. Now here you can see. Here we have taken A, B, C, D data with the combinations. Here you can see. This is called as scatter plot diagram. or graph. So many of the machine learning and data science applications, so these type of graphs are used for analysis of the data. Let us run this program and check the result. So here we already imported NPy, then Matplotlib also imported. Then you can take the random seed data, np dot random dot seed. Then data you are defining with labeled with A, C, D is the data. Then you are defining data of B, combination of A plus 10 into some calculation. Then data of D you are modifying, multiplied with 100. Then you are defining a plot with a restricted size of the figure 5, 2.7 height and width with the constrained type. Then you are defining a scatter plot using the method scatter with axis ax dot scatter. We are taking labeling A data, labeling B data, then C data, then D data. Then C and D we are storing in C and S. Here data equal to data. Then you are setting the labels of X and Y axis. X axis we are setting it as entry A. Whatever the name, if you want, you can give here. Here set underscore X label. This is the label of X axis. Similarly, label of Y axis ax dot set underscore y label. Here we are giving entry B. Then finally see the plot plt.show. You can see this is the graph what we have seen. So this diagram, if you want to, you can save, you can increase the size. Here you can see entry for A. This is the x-axis label. Then entry for B. Entry B. This is the y-axis label. So now this is the x-axis data. This is the y-axis data. So this format is called as scatter plot. For that we use scatter method. What it takes A, B, C data. 4 labels data. Combination is taken here. You can see the bubbles with different sizes. So this is the another example. So like that here you can give input to the plotting function by converting before that. Okay, that's all about the overview, installation and a simple example of Matplotlib. In next upcoming lecture, we will see some other topics related to Matplotlib. Till then, all of you stay tuned for latest updates.